The information and analysis provided in this presentation are intended strictly and exclusively for educational and entertainment purposes, and under no circumstances should this content be construed as professional financial, legal, tax, investment, or automotive purchasing advice. The modern landscape of electric vehicles, encompassing fluctuating federal and state tax incentives, unpredictable vehicle depreciation curves, evolving charging infrastructure development, and shifting global market dynamics, is inherently volatile and subject to rapid, unforeseen changes. Throughout this deep dive, we will be examining various historical trends, extensive market analyses, and detailed case studies from the automotive sector. However, these are presented solely for illustrative purposes to demonstrate potential outcomes regarding technology adoption and market shifts. They do not, in any capacity, reflect guaranteed future results or establish a definitive roadmap for personal wealth or asset appreciation. Deciding to purchase an electric vehicle, transition your household energy ecosystem, or invest in companies operating within the automotive and green energy sectors carries significant and inherent financial risks. Every individual's financial situation, daily commuting needs, and local geographical infrastructure are uniquely different. Therefore, all viewers are strongly advised and encouraged to conduct their own independent, exhaustive due diligence. Please research your specific local and regional charging infrastructure, understand the intricate details of your daily driving habits, and consult with certified financial advisors, tax professionals, and automotive specialists before making any major financial commitments or purchasing decisions related to the rapidly evolving electric vehicle market. Imagine it is 2 o'clock in the morning on Interstate 80, the massive sprawling artery that cuts directly through the heart of the American Midwest. For the better part of a century, the ambient soundtrack of this highway, and thousands of others just like it across the country, has been entirely uniform. It was the low, rumbling baritone of diesel engines from long-haul trucks hauling freight from coast to coast, intertwined with the mechanical, rhythmic hum of internal combustion engines carrying families, commuters, and road trippers through the night. The American highway system, envisioned and championed by President Dwight D. Eisenhower in the 1950s, was meticulously designed for gasoline. Our entire national geography of rest stops, convenience stores, suburban developments, and commercial hubs was built around the foundational assumption that vehicles require liquid fossil fuels to operate. The internal combustion engine did not just change how we travel. It fundamentally dictated the architecture of the United States. Yet, if you stand on an overpass looking down at that same stretch of Interstate 80 today, a profound and historically unprecedented transformation is unfolding right before your eyes, often moving so quietly that you might miss it if you are not paying close attention. Slicing through the darkness between the traditional diesel trucks and gas-powered sedans are sleek, aerodynamically optimized vehicles that emit almost zero engine noise. They represent a technological paradigm shift that is rewriting the rules of transportation, energy consumption, and personal mobility. We are currently witnessing the dawn of what economists and transportation engineers refer to as the S-curve of technological adoption. Historically, whenever a completely disruptive technology enters a mature market, whether it was the transition from horses to automobiles, the shift from typewriters to personal computers, or the mass migration from analog cell phones to internet-connected smartphones, the adoption rate does not move in a slow, steady, predictable straight line. Instead, it follows a very specific mathematical trajectory. For years, the new technology stumbles along at a 1 or 2% market share, plagued by high costs, limited infrastructure, and widespread consumer skepticism. It is dismissed by the established industry titans as a passing fad or a niche novelty for wealthy early adopters. But then an invisible threshold is crossed. The technology hits a critical tipping point, usually around the 5 to 10% market penetration mark. Suddenly, economies of scale kick in, manufacturing costs plummet, infrastructure rapidly expands to meet the surging demand, and the adoption curve shoots violently upward in a near-vertical trajectory. According to extensive market research and automotive sales data from the past 36 months, the United States automotive market has officially crossed that exact critical threshold. We are no longer waiting for the electric vehicle revolution to arrive in some distant science fiction future. We are currently living through the steepest and most disruptive acceleration phase of that historical curve. But this rapid acceleration is bringing a wave of profound consequences that the mainstream media is completely failing to adequately explain to the average consumer. There is a massive multi-billion-dollar pivot happening beneath the asphalt of our highways, a geopolitical race for critical battery minerals, and a fundamental restructuring of how we generate and distribute electricity. And there is a specific, hidden economic mechanism driving this shift that no one is talking about. An underlying reality that guarantees the automotive landscape will look entirely unrecognizable by the end of this decade. By the time we conclude this deep dive, you will understand exactly why the gas-powered car currently sitting in your driveway might become financially and practically obsolete much faster than you ever anticipated. For the average American driver, observing this chaotic transition from the outside is incredibly confusing, overwhelmingly frustrating, and fraught with financial anxiety. You are being bombarded with conflicting information from every possible direction. On one side, aggressive marketing campaigns are pushing you to embrace the electric future immediately, touting federal tax credits, zero tailpipe emissions, and the convenience of waking up with a fully charged vehicle every morning. On the other side, you hear alarming cautionary tales about public charging stations being broken, range anxiety leaving families stranded on holiday road trips in freezing weather, and horrific stories of out-of-warranty battery replacement costs that rival the price of a brand new car. You are standing at a critical financial and lifestyle crossroads, trying to figure out what this historic shift actually means for your wallet, your daily commute, and your family's safety. The problem you are facing today is a massive deficit of clear, unbiased, and mechanically sound information. You need to know if transitioning to an electric vehicle makes logical sense for your specific living situation, or if it is a costly mistake waiting to happen. You need to understand the vast and critical differences between Level 1, Level 2, and Level 3 charging infrastructure, and why plugging a car into a standard wall outlet is vastly different from utilizing a high-voltage direct current fast charger. You need to comprehend how extreme temperatures, both hot and cold, physically alter the chemical properties of lithium-ion battery cells and drastically reduce your driving range. This comprehensive masterclass is designed to be the ultimate, foundational blueprint for navigating the great American automotive transition. We are going to strip away the marketing jargon and the political noise to examine the raw engineering, the economic realities, and the historical trends shaping this industry. We will systematically break down the complexities of battery degradation, grid capacity, and total cost of ownership over a 10-year horizon. We will explore detailed case studies of drivers across various climates, from the sub-zero winters of the upper Midwest to the scorching summers of the Southwest, to illustrate the potential outcomes and the harsh realities of relying on electric propulsion. By equipping you with this deep, technical, and economic understanding, you will be empowered to make incredibly informed decisions about your next vehicle purchase, ensuring that you are completely prepared for the silent revolution that is currently taking over American highways. Imagine David, a mid-level logistics manager living in the sprawling, heavily trafficked suburbs of Atlanta, in this current year of 2026. For the past 2 decades, David has blindly accepted a very specific, deeply ingrained mechanical routine. Every Tuesday and Friday morning, regardless of the weather, he factors an extra 15 minutes into his daily commute simply to pull his vehicle into the local commercial gas station. He navigates the concrete islands, swipes his credit card, stands in the freezing cold or the sweltering heat, watches the digital numbers on the pump spin rapidly upward, and calculates the ever-shifting, highly volatile percentage of his monthly household income dedicated exclusively to the act of moving his physical body from his residence to his corporate office. David represents the ultimate traditional American commuter, permanently locked into a century-old macro infrastructure designed entirely around the constant, uninterrupted extraction, global transportation, refining, and local distribution of highly combustible liquid petroleum. But historical trends from the last 5 years have completely fractured David's routine and the routines of millions of other drivers across the country. Let us systematically examine the exact mathematical and engineering shift that forced millions of Americans to permanently abandon the internal combustion engine. To truly understand this mass migration, we must conduct a deep dive into the concept of total cost of ownership, widely referred to in the automotive industry as TCO. For many decades, the staggering upfront sticker price of a battery-powered vehicle acted as a massive, impenetrable financial fortress wall, effectively keeping the average middle-class consumer locked out of the market. However, extensive market analyses and longitudinal fleet data reveal that the true economic battleground was never actually the dealership showroom floor. It was the residential driveway calculated over a comprehensive 7-year ownership lifespan. Step by step, the underlying production cost of advanced lithium-ion battery packs has plummeted from well over $1,000 per kilowatt-hour in the early 2000s to firmly below the critical, industry-altering threshold of $100 per kilowatt-hour today. This remarkable price collapse is not a sudden miracle of science. It is the brutal, highly predictable efficiency of automated mass manufacturing, scaling up globally. To grasp the true magnitude of this operational savings, you must understand the fundamental laws of thermodynamics that govern your daily commute. A traditional gasoline engine is an inherently wasteful machine. When you ignite liquid fuel in a standard internal combustion engine, approximately 70 to 80% of the potential energy contained within that gasoline is violently lost as raw heat, friction, and exhaust noise. You are paying for a gallon of fuel, but only utilizing a tiny fraction of it to actually propel your vehicle forward. In stark contrast, a modern electric drivetrain converts over 90% of its electrical energy directly into rotational force at the wheels. When you eliminate the sheer necessity for multi-grade motor oil changes, complex transmission fluid flushes, spark plug replacements, failing catalytic converters, and snapping timing belts, you strip away thousands of moving mechanical components that are purposefully engineered to degrade, wear out, and eventually fail over time. We are seeing extensive case studies of massive municipal fleet operators in states like California and Texas reporting a staggering 50 to 70% reduction in their annual preventative maintenance budgets, simply by transitioning their light-duty patrol and service vehicles from gasoline to battery electric propulsion systems. But the sheer economic argument of lower daily operating costs was never going to be enough to completely rewrite the physical landscape of the American highway system. The concrete infrastructure itself had to rapidly and aggressively mutate. Imagine if, back in the year 1925, you were forced to construct a fully functioning miniature oil refinery in your own backyard just to have the privilege of driving to work. That extreme friction is precisely how early electric vehicle adoption felt to the average cautious consumer. Now, carefully analyze the present reality of the massive national electric vehicle infrastructure rollout. By strategically injecting billions of dollars of coordinated capital directly into state-level highway corridors, the national transportation map has been fundamentally redrawn. We have completely transitioned away from isolated, broken low-voltage charging stalls hidden in the dark corners of abandoned shopping malls. Today, we navigate toward highly visible, brilliantly illuminated, hyper-fast direct current public charging plazas located precisely every 50 miles along every major interstate artery in the country. Let us meticulously break down the actual mechanics of what happens when David plugs his new vehicle into one of these modern, high-capacity electrical dispensers. He is no longer dealing with a slow, agonizing trickle of alternating current over several hours. He is utilizing an advanced 800-volt vehicle architecture that violently pushes electrons into the battery cells with such precision and ferocity that the vehicle gains over 200 miles of driving range in the exact amount of time it takes him to walk inside the travel center, purchase a cup of black coffee, and use the restroom. Furthermore, the software integration has eliminated the early chaos of the industry. Through secure cryptographic protocols known as plug and charge, the vehicle instantly communicates its unique identification number, banking information, and battery state of charge directly through the liquid-cooled charging cable the millisecond it is connected. No swiping cards, no proprietary mobile applications, no frustrating authentication errors. The severe psychological barrier known as range anxiety, which successfully paralyzed mainstream consumer adoption for over a decade, is being systematically dismantled by a combination of raw chemical engineering and brute force infrastructure deployment. Furthermore, this technological revolution extends far beyond the public interstate highway. It is currently permeating the very foundation of the American residential home. Consider the highly disruptive concept of bidirectional charging, which has rapidly transitioned from a theoretical luxury feature for early adopters into a standard, heavily utilized utility function in 2026. When David returns to his suburban Atlanta neighborhood after a long day at the office, his vehicle does not merely sit dormant inside the garage, slowly depreciating in value while taking up physical space. Through advanced home integration software, it instantly transforms into a massive rolling home energy storage system. During the peak late afternoon hours when regional utility rates skyrocket due to heavy air conditioning usage across the state, his house intelligently stops pulling power from the grid and instead draws clean electricity directly from the massive battery pack sitting inside the vehicle. In the middle of the night, when grid demand completely collapses and regional electricity costs fractions of a penny per kilowatt, the vehicle silently and automatically replenishes itself. This dynamic automated load shifting represents a potential outcome where the vehicle actively offsets its own operating costs by engaging in daily, micro-level energy arbitrage. This seamless, intelligent integration between the residential driveway and the massive local power utility infrastructure sounds like a perfect, frictionless utopian outcome for the modern American family. It points toward a future of total energy independence, incredible household emergency preparedness, and unprecedented long-term financial efficiency. But lurking just beneath the highly polished surface of this localized, neighborhood-level power sharing lies a deeply concerning, systemic national vulnerability that major utility companies are currently scrambling to manage and desperately trying to keep out of the evening news cycle. When tens of millions of highly advanced, incredibly energy-hungry machines simultaneously plug into a fragile national grid system that was fundamentally designed and constructed in the middle of the 20th century, the harsh physical laws of electricity begin to violently clash with aging copper wires and overloaded transformers. And the shocking, unfiltered reality of what happens to our national infrastructure when entire sprawling suburban neighborhoods attempt to fast-charge their vehicles at the exact same moment will fundamentally change everything you thought you knew about American energy security. To comprehend the sheer magnitude of this looming electrical bottleneck, we must strip away the sleek, futuristic marketing of electric vehicles and examine the raw, unforgiving physics of power distribution. For over a century, the American electrical grid has operated on a fundamental principle of real-time supply and demand. Electricity is not easily stored on a massive utility-scale level. It must be generated at the exact millisecond it is consumed. The entire continental system is meticulously balanced to maintain a very specific frequency of exactly 60 Hz. If the demand for power suddenly outpaces the supply, the frequency drops, leading to rolling blackouts, damaged industrial equipment, and catastrophic infrastructure failure. Now introduce millions of massive, energy-dense lithium-ion battery packs into this highly delicate ecosystem. Imagine if we analyze the specific case study of Michael, a homeowner living in a sprawling, densely populated subdivision in Phoenix, Arizona, during a brutal summer heat wave in this current year of 2026. At precisely 5:30 in the evening, the ambient outdoor temperature is still hovering around 110 degrees Fahrenheit. Michael pulls his heavy-duty electric pickup truck into his garage. The vehicle's internal thermal management system has already been working overtime during his commute, utilizing energy just to keep the liquid-cooled battery pack at an optimal operating temperature. He steps out and plugs his vehicle into a newly installed 48-amp Level 2 home charging station. To put the sheer electrical draw of this action into perspective, a standard central air conditioning unit running at maximum capacity might draw roughly 3 to 5 kilowatts of continuous power. Michael's electric truck, the moment it is plugged in, begins pulling 11.5 kilowatts. By simply connecting his vehicle to the wall, Michael has effectively added the electrical equivalent of 3 entire central air conditioning systems to his home's immediate energy consumption. Now, multiply Michael's actions by the 300 other homes in his immediate neighborhood. Historical trends regarding American commuting habits show that the vast majority of the workforce arrives home within a highly concentrated 90-minute window in the late afternoon. They all arrive home. They all plug in their vehicles. Simultaneously, their household central air conditioners are already running at maximum capacity to fight the intense desert heat. Electric ovens are turned on to prepare dinner. Televisions and computers are powered up. The localized step-down transformer, that unassuming cylindrical metal canister sitting atop the wooden utility pole at the end of Michael's street, was likely installed in the late 1990s. It was engineered and deployed based on residential load calculations from a completely different era, an era when the heaviest electrical draw a home could possibly produce was a domestic clothes dryer or an electric water heater. Now, that exact same aging transformer is suddenly being asked to process the continuous electrical load equivalent of a small industrial manufacturing facility. The physical engineering reality of what happens next inside that transformer is alarming utility providers across the nation. These distribution transformers are filled with specialized mineral oil, designed to cool the internal copper windings as electricity flows through them. As the neighborhood load pushes past the engineered capacity, the internal temperature of those copper windings skyrockets. The protective mineral oil begins to literally boil. If the thermal limits of the equipment are exceeded for too long, the internal insulation paper degrades rapidly, inevitably leading to a catastrophic internal short circuit. The transformer violently fails, plunging the entire neighborhood subdivision into darkness right at the peak of a lethal heat wave. This is not a hypothetical, exaggerated science fiction scenario. Grid operators and utility dispatchers are actively analyzing massive data sets from recent peak demand events and realizing that highly localized grid failures are one of the most pressing potential outcomes of unmanaged, localized electric vehicle adoption. This stark reality forces the massive, highly regulated utility companies into a multi-trillion-dollar race against time. The traditional, century-old method of grid management was entirely reactive and highly carbon-intensive. When demand spiked, grid dispatchers would simply fire up massive, centralized natural gas peaker plants and violently push more electrons down the high-voltage transmission lines. But physically replacing millions of neighborhood transformers, upgrading thousands of miles of subterranean copper wiring, and building new power plants is a logistical and bureaucratic nightmare that would take decades to complete. Furthermore, the astronomical capital required for these physical upgrades would ultimately be passed directly onto the consumer through wildly inflated monthly electric bills, completely destroying the economic advantage of owning an electric vehicle in the first place. Therefore, the entire energy industry is executing a massive pivot toward a radical new concept, known as grid-edge computing and active demand response. Instead of blindly attempting to rebuild the physical copper infrastructure overnight, utility companies in 2026 are heavily relying on advanced telematics, artificial intelligence, and behavioral economics to actively manipulate when and how vehicles charge. They are utilizing dynamic, real-time pricing algorithms to fundamentally alter human behavior at the neighborhood level. Michael does not actually need his electric truck to charge the exact second he arrives home at 5:30. He simply needs the battery pack to be fully replenished by 7 o'clock the next morning when he leaves for work. Through deep software integration between the local utility provider and the vehicle's onboard computer network, Michael opts into a managed smart charging program. He plugs the heavy cable into his truck, but absolutely no electricity flows immediately. The utility company's master control servers constantly monitor the local neighborhood load, visually detecting that the street-level transformers are dangerously approaching their maximum thermal limits, and artificially throttle or completely pause the charging speeds across the entire subdivision. As the evening progresses, the sun sets, outdoor temperatures drop, and high-draw household appliances cycle off, suddenly freeing up massive amounts of localized grid capacity. Only then, perhaps at 1 o'clock in the morning when regional electricity costs are exceptionally low, does the utility send an encrypted digital handshake directly to Michael's vehicle. This invisible signal silently commands the high-voltage contactors to close, finally flooding the battery pack with cheap, abundant, off-peak electricity. This highly synchronized energy ecosystem relies entirely on the assumption that we have total uninterrupted software control over the physical vehicles and the massive battery packs contained within them. We have engineered a brilliant, invisible digital ballet to manage the flow of electricity, assuming that the physical batteries themselves will always be readily available, perfectly manufactured, and infinitely scalable to meet the skyrocketing consumer demand. But as we peel back the polished layers of this technological marvel, a much darker, incredibly complex global reality begins to surface. The software running the American grid might be flawlessly designed by engineers in Silicon Valley, and the sleek vehicles might be heavily assembled in massive automated factories across Texas and Michigan, but the elemental foundation of this entire revolution, the raw, chemical lifeblood that allows these vehicles to store energy in the first place, is quietly triggering a global crisis that almost no average consumer sees coming. To truly grasp the magnitude of this invisible bottleneck, we must look past the polished touchscreen interfaces and the aerodynamic exterior designs of these modern machines to examine the brutal, elemental reality resting beneath the floorboards. The heart of every electric vehicle on an American highway in 2026 is not a mechanical engine. It is a highly complex, incredibly dense electrochemical vault. Shutterstock. When you purchase an extended-range electric SUV weighing over 6,000 pounds, you are fundamentally purchasing a rolling chemical processing plant. Inside that heavily armored rectangular pack sitting beneath your feet are thousands of individual cylindrical or prismatic battery cells. To manufacture just one single long-range battery pack capable of pushing a heavy vehicle over 300 miles on a single charge, the global supply chain must aggressively extract, transport, and perfectly refine roughly 18 pounds of lithium, 77 pounds of nickel, 44 pounds of manganese, 30 pounds of cobalt, and nearly 200 pounds of processed graphite. But those are just the refined final numbers. The historical trends of global mining dictate a much harsher logistical equation. To yield those specific, highly purified quantities, heavy machinery must physically dig up, crush and process approximately 500,000 pounds of raw earth for every single vehicle that rolls off the assembly line. Now multiply that staggering volume of displaced earth by the tens of millions of electric vehicles mandated to hit American roads by the end of this decade. This astronomical demand for critical minerals has ignited a geopolitical scramble that fiercely rivals the industrial rush for crude oil in the 20th century. Consider the case study of Sarah, a senior procurement director for a rapidly scaling automotive manufacturer based in Detroit in the year 2026. Her entire professional existence is defined by securing multi-year contracts for these specific elemental building blocks. Sarah does not worry about the availability of steel or aluminum. She is locked in a high-stakes, multi-billion-dollar chess match for battery-grade lithium carbonate and nickel sulfate. When Sarah looks at the global map, she sees a deeply fractured and highly concentrated supply chain that presents immense potential outcomes for national security and domestic economic stability. She knows that the raw lithium required for her company's battery packs does not magically appear in the Midwest. It originates in the desolate, high-altitude salt flats of the South American Lithium Triangle, where millions of gallons of underground brine are pumped to the surface and left to evaporate under the harsh desert sun for up to 18 months. Alternatively, it is blasted out of massive open-pit hard rock mines in Western Australia. Imagine if the United States automotive industry relied on a process where the raw materials necessary to build a vehicle took over a year and a half simply to extract from the earth before they could even be shipped. That is the current reality of the brine evaporation process. But extraction is merely the first, incredibly slow step in a deeply vulnerable global marathon. Once that raw lithium or cobalt is finally pulled from the earth, it is almost never processed in the country of origin. Instead, the raw ore is loaded onto massive, diesel-burning cargo ships and transported thousands of miles across the ocean to undergo an incredibly energy-intensive and highly toxic refining process. This is the exact choke point where the American electric vehicle transition faces its most severe vulnerability. Historically, the United States completely outsourced the messy, environmentally hazardous business of chemical refining to overseas markets. By the time the massive automotive transition hit its exponential acceleration phase, a singular foreign superpower had systematically cornered roughly 80% of the global processing capacity for advanced battery materials. They do not necessarily own all the mines, but they own the incredibly complex, multi-billion-dollar chemical refineries that turn raw dirt into the highly purified precursor materials that actually make a battery function. For Sarah in Detroit, this means that even if an American company successfully opens a new lithium mine in Nevada, that raw domestic ore must often be shipped completely across the Pacific Ocean to be refined, only to be shipped all the way back to the United States to be placed into a battery cell. This extreme geographical concentration of refining capacity introduces catastrophic risks to the American consumer. You might walk into a dealership in Texas or Florida, ready to purchase a new electric vehicle, completely unaware that the sticker price on the window is violently fluctuating based on geopolitical tensions occurring 10,000 miles away. If a sudden diplomatic dispute, an international trade embargo, or a regional conflict suddenly disrupts the maritime shipping lanes carrying these refined chemicals, the American automotive assembly lines would grind to a devastating halt within weeks. We are witnessing potential outcomes where the availability of personal transportation in the United States is entirely dependent on the operational capacity of overseas chemical plants. Furthermore, the elemental chemistry of these batteries is directly tied to deeply concerning ethical and environmental realities. Take cobalt, for example. This specific blue-gray metal is absolutely critical for stabilizing the cathode of a battery cell, preventing it from overheating and catching fire during high-speed charging sessions. However, historical trends and extensive supply chain audits consistently reveal that the vast majority of the world's cobalt is extracted from the Democratic Republic of Congo. Despite massive corporate compliance efforts, tracking the exact origin of this specific mineral is incredibly difficult, leading to persistent, severe concerns regarding unregulated artisanal mining practices and unsafe labor conditions. American automakers are desperately engineering new battery chemistries to completely eliminate cobalt from the equation, pivoting toward lithium iron phosphate architectures, but these alternative chemistries inherently possess lower energy densities, meaning the vehicle cannot drive as far on a single charge, thereby resurrecting the ghost of range anxiety for the cautious consumer. The sheer economic weight of this supply chain bottleneck is actively forcing a radical, unprecedented shift in how American manufacturing operates. To survive this elemental chokehold, legacy automakers are no longer just building cars. They are desperately transforming into massive, vertically integrated chemical companies. They are pouring billions of dollars directly into domestic mining startups, attempting to build a closed-loop supply chain entirely within the borders of North America. But building a hyper-advanced chemical refinery takes years of intense regulatory permitting, billions in upfront capital, and massive environmental impact studies. As we stand in 2026, the gap between the explosive consumer demand for electric vehicles and the physical reality of our domestic mineral supply chain is stretching to an absolute breaking point. And this massive industrial friction leads us to the most fiercely debated, highly controversial component resting underneath the floor of these modern vehicles. It is the single, most expensive part of the entire machine, and its inevitable chemical degradation over time is terrifying millions of potential buyers, creating a massive secondary market crisis that threatens to collapse the entire financial model of electric vehicle ownership. To truly comprehend the sheer terror gripping the secondary automotive market, imagine if we examine the specific financial situation of Robert, a high school administrator living in the sprawling suburbs of Columbus, Ohio, in this current year of 2026. Robert is actively seeking to replace his aging, heavily driven gasoline-powered sedan. He walks onto the asphalt lot of a massive regional dealership and is immediately drawn to a sleek, beautifully maintained 4-year-old electric crossover vehicle. When this specific machine rolled off the assembly line brand new in 2022, the original window sticker price hovered near $65,000. Today, Robert is staring at a sharply discounted, highly aggressive price tag of merely $24,000. To the untrained, traditional consumer eye, this massive depreciation looks like the ultimate automotive bargain, an incredible opportunity for a middle-class family to finally enter the premium electric vehicle ecosystem. But resting silently beneath the pristine leather seats and the massive panoramic glass roof lies a highly complex, electrochemical ticking clock that traditional automotive financing models and neighborhood banking institutions were entirely unprepared to handle. The fundamental problem is that Robert is not actually evaluating a mechanical vehicle. He is evaluating a massive, degrading chemical vault. To understand his true financial exposure, we must execute a deep dive into the microscopic violence that occurs inside a lithium-ion battery cell every single time the vehicle is driven, charged, and exposed to the harsh elements. A high-capacity battery pack does not simply hold electricity in the same static, predictable manner that a plastic tank holds liquid gasoline. It is an intensely dynamic, highly volatile physical environment where millions of lithium ions are forced to physically swim back and forth between a graphite anode and a complex metal oxide cathode, suspended in a liquid chemical electrolyte. Every single time those microscopic ions make that journey during a standard daily commute, minute physical damage occurs within the internal architecture of the cell. This cellular damage dramatically accelerates under specific conditions. When the previous owner utilized a direct current fast charger, aggressively pushing massive amounts of high-voltage electricity into the vehicle to save time on a road trip, the sheer velocity and thermal heat of those forced ions cause them to occasionally stack up unevenly on the anode. This aggressive charging creates microscopic, needle-like metallic structures known as dendrites, which slowly pierce the internal separators of the battery. Furthermore, constantly operating and storing the vehicle in extreme ambient temperatures, such as the bitter, freezing cold of an Ohio winter or the blistering, radiant heat of a summer afternoon, forces the chemical reactions to become highly inefficient. Over time, this thermal stress permanently consumes the active lithium inventory inside the cell, thickening a microscopic barrier known as the solid electrolyte interphase layer. Over 4 years of daily commuting, these invisible microscopic injuries compound exponentially, permanently reducing the physical capacity of the pack to store energy. The automotive industry refers to this gradual, inevitable loss of capacity as battery degradation, and it is the single most terrifying financial variable in the entire electric transition. If Robert were to purchase a traditional internal combustion vehicle with 100,000 miles on the mechanical odometer, he would fully expect certain predictable mechanical failures. A water pump might suddenly leak, a timing belt might snap, or perhaps the transmission would eventually require a complete rebuild. These are known, historically quantifiable risks that might cost him $2,000 or $3,000 at a local independent mechanic shop. However, if the massive, structurally integrated battery pack inside his used electric crossover fails completely outside of the manufacturer's warranty period, Robert is not facing a simple routine repair bill. He is facing a catastrophic, completely ruinous financial event. The specialized labor and raw material costs required to entirely drop, diagnose, and replace a high-capacity liquid-cooled battery pack at a certified dealership in 2026 can easily range between $16,000 and $22,000. This singular repair bill effectively exceeds the entire residual market value of the used vehicle itself, instantly rendering the car a total financial loss. This stark, terrifying mathematical reality has triggered a massive systemic crisis in the secondary automotive market. Historical trends heavily documented over the past 36 months have shown massive institutional fleet operators, including national rental car conglomerates, aggressively liquidating their massive electric vehicle inventories at staggering, unprecedented financial losses simply because the depreciation curves became mathematically unsustainable. Dealerships across the country are suddenly paralyzed by immense financial risk. They possess incredibly advanced diagnostic tools to inspect the compression of an engine block in a gasoline car, but accurately assessing the internal chemical health of an enclosed, high-voltage electric vehicle battery pack remains incredibly complex and highly restricted. Consequently, wholesale buyers and dealership appraisers are fiercely protecting their profit margins by aggressively lowering the trade-in values of electric vehicles across the board. When an average consumer attempts to trade in their 3-year-old electric car today, they are often completely shocked to discover they are massively underwater on their auto loan, owing thousands of dollars more to the banking institution than the physical vehicle is actually worth in the open wholesale market. This absolute collapse in residual consumer confidence has forced the entire automotive industry to rapidly pivot away from the traditional concept of vehicle mileage. In the year 2026, the physical odometer reading displayed on the dashboard is becoming entirely irrelevant to the true value of the machine. The only metric that truly dictates the financial worth of a used electric vehicle in the secondary market is a deeply embedded software calculation known as the state of health. This singular percentage mathematically represents the exact amount of chemical capacity remaining in the pack compared to the specific day it rolled off the assembly line. But accessing this critical, deeply buried data is often fiercely restricted behind proprietary software walls heavily guarded by the original manufacturers. Independent used car dealers and private buyers are frequently left blindly guessing at the true condition of the single most expensive component in the entire vehicle. This massive asymmetry of information means that purchasing a used electric vehicle heavily resembles a high-stakes financial gamble, where the buyer is actively placing a $20,000 bet on the historical, entirely undocumented charging habits of the previous, anonymous owner. The massive multinational automotive conglomerates are acutely aware of this escalating disaster. They know with absolute certainty that if the secondary used car market completely collapses under the weight of battery replacement anxiety, the entire foundational adoption curve for brand new vehicles will violently shatter. If mainstream consumers realize their expensive new electric car will be practically worthless and unsellable in 5 years, the primary sales pipeline will immediately freeze. To prevent this catastrophic financial implosion, the industry is currently executing a highly secretive, deeply complex operational pivot to fundamentally alter the very concept of physical vehicle ownership. They are no longer looking at that aging, degrading battery pack in your driveway as a future liability destined to be discarded in a toxic landfill. Instead, they view it as a highly valuable, heavily guarded chemical asset that must be reclaimed and harvested at all costs. And to guarantee they eventually get those precious raw materials back into their controlled supply chains, they are aggressively deploying a controversial, heavily integrated software tethering mechanism that completely changes who actually owns the hardware resting inside your garage. To completely understand this radical and deeply unsettling shift in fundamental consumer rights, imagine if we analyze the specific, highly documented purchasing experience of Thomas, a senior systems architect living in the rapidly expanding tech corridors of Denver, Colorado, in this current year of 2026. Thomas has just proudly signed the final digital paperwork on a brand new, exceptionally advanced electric sport utility vehicle. In the historical 20th century model of automotive purchasing, the moment Thomas handed over his cashier's check, the physical machine and every single component bolted to its chassis became his exclusive, sovereign private property. He could modify it, disassemble it, leave it to rust in a field, or sell it to a neighbor without ever asking the original manufacturer for permission. But as Thomas drives his silent new vehicle off the brightly lit dealership lot today, He is completely unaware that he has not actually purchased an automobile in the traditional historical sense. Instead, he has unknowingly entered into a massive, legally binding, permanent digital tethering agreement. He has effectively purchased a heavily fortified rolling computer terminal, and he is merely licensing the highly restricted software required to make the physical electric motors turn. The foundation of this extreme transition revolves around a controversial economic model, known within the automotive industry as hardware as a service, heavily driven by the deployment of over-the-air software updates. Let us break down the exact mechanical and economic reality resting inside Thomas's new vehicle. When the massive assembly plant in Michigan manufactured his specific car, they did not build multiple different versions of the battery pack to satisfy different consumer price points. Running multiple distinct assembly lines for a 60 kilowatt-hour battery, an 80 kilowatt-hour battery, and a 100 kilowatt-hour battery is incredibly inefficient and destroys profit margins. Therefore, to achieve absolute maximum economies of scale, the manufacturer physically installed the exact same massive, highly expensive 100 kilowatt-hour battery pack into every single vehicle rolling down the production line, regardless of what the final customer actually paid for. Because Thomas opted for the base model to save money on his monthly payments, the manufacturer utilized a deeply embedded line of encrypted code to artificially and digitally lock his massive physical battery pack at a strict 60% capacity. This means Thomas is physically hauling around hundreds of pounds of highly refined lithium, nickel, and cobalt everywhere he goes, expending extra electrical energy simply to carry the dead weight of a dormant chemical vault that he is completely blocked from accessing. Now imagine if a severe winter blizzard strikes the Denver metropolitan area, and Thomas urgently needs extra driving range to safely evacuate his family or reach a distant hospital. The physical capability to drive those extra 80 miles is already resting securely underneath his feet. The chemical potential is sitting right there in his driveway, but to access it, he must open a proprietary application on his smartphone, enter his credit card information, and pay the manufacturer a massive, one-time emergency unlock fee, or subscribe to a monthly high-capacity tier. The manufacturer's centralized server then beams a tiny digital encrypted handshake through the vehicle's permanent cellular connection, silently commanding the battery management system to release the artificial bottleneck and allow the electrons to flow. This effectively transforms the physical hardware inside a private citizen's garage into a permanent, highly lucrative recurring revenue stream for the corporation. But the financial extraction does not stop at artificial battery limitations. This heavy software tethering is the exact mechanism legacy automakers are actively weaponizing to solve the massive, multi-billion-dollar critical mineral shortage we discussed previously. The global supply chain for raw lithium and cobalt is highly volatile and deeply vulnerable to geopolitical conflict. Therefore, the most valuable gold mine on the planet for an automotive manufacturer in 2026 is not a massive open-pit excavation site in South America. It is the millions of aging, degrading battery packs currently sitting inside the vehicles of their own customers. The industry desperately needs those physical battery cells back at the end of their operational lifespan. They intend to systematically crush them into a highly toxic, valuable powder known as black mass, completely dissolve them in industrial acid through an advanced chemical process called hydrometallurgy, and perfectly extract the raw, purified elements to build the next generation of vehicles. This concept, known as closed-loop urban mining, is absolutely essential for the survival of the domestic automotive industry. However, the corporations cannot physically force private citizens to return their property if the citizens legally own the battery. To guarantee they maintain total uninterrupted physical control over these critical chemical assets, automakers are aggressively leveraging the software tether to push consumers entirely away from traditional purchasing and directly into mandatory, restrictive battery leasing programs. When Thomas evaluates his contract deeply, he realizes he purchased the steel chassis, the glass windows, and the rubber tires, but he is perpetually leasing the electrochemical vault beneath the floorboards. If he attempts to physically tamper with the battery, sell it to an unauthorized third-party recycler, or stop paying his monthly subscription fee, the manufacturer holds the ultimate, terrifying leverage. Through a single, silent over-the-air update sent directly from their corporate headquarters, they can instantly brick the entire vehicle. They can digitally sever the connection between the high-voltage contactors and the electric drivetrain, immediately turning his $60,000 primary mode of transportation into a completely paralyzed, unmovable steel brick resting uselessly in his driveway. This unprecedented level of centralized corporate control over physical, personal mobility represents one of the most drastic shifts in consumer property rights in modern American history. The vehicle has fundamentally transformed from a tool of absolute personal freedom into a heavily monitored, constantly connected node on a corporate network. And the sheer volume of data required to maintain this complex, digital tethering system is staggering. Every single millisecond, Thomas's vehicle is generating, logging, and wirelessly transmitting gigabytes of highly sensitive telemetry data directly back to the manufacturer's server farms. The cameras are recording the exact physical dimensions of his garage. The weight sensors in the seats know precisely how many passengers are in the vehicle. The navigation system maps his daily routine down to the exact second he drops his children off at school. The battery management system is constantly analyzing the precise physical pressure he applies to the accelerator pedal. This highly intimate, granular data is not simply being used to improve battery efficiency or deploy software updates. It is quietly becoming the most valuable, heavily traded commodity in the entire global automotive ecosystem. And as we examine the massive, hidden data broker industry currently operating completely out of sight of the average consumer, we will uncover exactly how this constant stream of highly personal telemetry is being silently packaged, monetized, and directly weaponized by massive third-party financial institutions to fundamentally alter the cost of your daily existence. To comprehend exactly how this invisible data economy operates and profoundly impacts your financial reality, imagine if we analyze the highly documented case study of Jessica, an experienced emergency room nurse living in the densely populated urban grid of Chicago, Illinois, in this current year of 2026. 6 months ago, Jessica purchased a technologically advanced, fully electric sedan to navigate her demanding daily commute to the hospital. When she took delivery of the vehicle, she sat in the driver's seat, stared at the massive central touchscreen, and was immediately confronted with a 50-page digital terms of service agreement. Eager to simply drive her new vehicle home, and conditioned by decades of casually accepting software agreements on personal smartphones, Jessica quickly scrolled to the bottom of the glowing screen and tapped the accept button. In that singular, seemingly innocuous moment, she legally consented to the systematic, unregulated harvesting of her daily physical existence. Her modern electric vehicle is fundamentally vastly different from the mechanical gasoline cars of the past century. It is essentially a heavy-duty, rolling data center equipped with a permanent, unseverable fifth-generation cellular uplink. The entire physical architecture of the vehicle relies on a massive array of internal and external sensors. There are high-definition cameras monitoring her eye movements to ensure driver attentiveness, ultrasonic sensors calculating the exact distance to surrounding traffic, highly sensitive internal microphones, and an advanced inertial measurement unit tracking longitudinal and lateral gravitational forces. Every single time Jessica presses the accelerator pedal, every time she abruptly applies the regenerative braking system to avoid a massive Chicago pothole, and every time she unbuckles her seatbelt, a highly compressed packet of encrypted digital telemetry is instantly generated, logged by the internal telematics control unit, and beamed directly to the massive cloud servers owned by the automotive manufacturer. For the first few months of ownership, Jessica believed this constant stream of data was utilized exclusively for benign engineering purposes, perhaps to optimize battery thermal management during the freezing Midwestern winter, or to send preventative maintenance alerts to her smartphone. However, historical trends spanning the massive technological shift of the past decade reveal a much more lucrative corporate strategy. The automotive manufacturer is not merely storing Jessica's telemetry data in a secure vault. They are actively and automatically packaging it into highly detailed behavioral profiles and selling it wholesale to massive multi-billion-dollar third-party data brokerages. These invisible data clearinghouses act as unregulated digital middlemen, aggregating petabytes of deeply personal mobility data from millions of American drivers every single day. The financial weaponization of this data occurs when these massive brokerages establish lucrative partnerships with the national auto insurance industry. For nearly a century, actuarial science relied on relatively static, historical data points to calculate your insurance premium. They looked at your zip code, your age, your marital status, and your official motor vehicle accident record. It was a deeply imperfect, generalized system of risk assessment. But in 2026, the insurance industry has completely transitioned to hyper-personalized, algorithmic underwriting fueled entirely by the constant stream of raw data harvested directly from your electric vehicle. Let us systematically examine how this dynamic pricing model financially devastates Jessica. Despite possessing a completely flawless official driving record with absolutely zero traffic citations and zero collisions in her entire life, Jessica suddenly receives a digital notification that her auto insurance premium has been aggressively increased by 45%. Bewildered and frustrated, she contacts her insurance provider, only to be met by a customer service representative who references a proprietary algorithmic risk score. Because Jessica works grueling 12-hour shifts at the hospital emergency room, her vehicle telemetry proves that she frequently navigates the highway system between the hours of 2 and 4 in the morning. Statistical algorithms heavily penalize late-night driving due to a historically higher probability of encountering intoxicated drivers or severe fatigue. Furthermore, because Jessica often has to utilize hard, evasive braking maneuvers to avoid sudden urban hazards on poorly lit streets, the data broker categorizes her as an erratic, high-risk driver. Jessica is actively being penalized and financially punished for her completely legal, entirely necessary daily routine. She is not being evaluated by a human underwriter. She is being ruthlessly processed by a blind machine learning algorithm that lacks any contextual understanding of her environment. The insurance algorithm does not know she is braking to avoid a stray animal or a dangerous sinkhole. It simply registers an extreme deceleration event and immediately incrementally raises her financial liability score. This introduces a terrifying potential outcome where American citizens are slowly priced out of personal mobility, not because they are inherently dangerous drivers, but because their unavoidable daily schedules conflict with the optimal parameters of a profit-driven risk algorithm. This inescapable surveillance ecosystem effectively forces a chilling behavioral modification upon the American public. When you are acutely aware that every micro-movement of your steering wheel, the exact speed you navigate a freeway off-ramp, and the precise volume of your radio are being actively tracked and monetized against your bank account, the fundamental psychological experience of driving completely transforms. The open American highway, historically romanticized as the ultimate symbol of personal freedom and untethered exploration, is rapidly becoming a strictly monitored, highly penalized digital panopticon. Consumers are trapped in a vicious, unbreakable cycle. You cannot simply sever the vehicle's cellular antenna to stop the data flow, because modern electric vehicles require a constant internet connection to manage the highly volatile thermal state of the high-voltage battery pack and to receive critical, mandatory safety updates. If the vehicle detects a loss of connectivity, it will eventually enter a restricted performance mode or refuse to operate entirely. The physical hardware of the electric car in your garage is completely locked by the manufacturer. The vital software required to make the motors turn is perpetually leased to you through the threat of remote deactivation. And the intensely personal, highly lucrative data generated by your daily physical movements is constantly extracted, sold, and utilized to incrementally increase the cost of your daily existence. You are no longer just a driver navigating from point A to point B. You have been transformed into a captive, continuous revenue stream for a massive, intertwined network of automotive manufacturers, tech conglomerates, and financial institutions. But this massive, invisible data harvesting infrastructure does not solely benefit private corporations seeking to maximize their quarterly profit margins. As millions of American drivers actively transition away from traditional gasoline-powered vehicles to embrace this heavily monitored electric ecosystem, a massive multi-billion-dollar crater is violently tearing through the budget of every single state government in the nation. For nearly a century, the physical maintenance of our bridges, tunnels, and interstate highways has been funded almost entirely by a hidden, deeply ingrained taxation system that is currently facing complete and total extinction. And as state transportation departments watch their primary source of infrastructure revenue completely evaporate, they are actively looking at the exact same constant, inescapable stream of vehicle telemetry data as the ultimate, highly controversial weapon to fundamentally restructure how you pay to drive on public roads. For nearly a century, the fundamental economic model supporting the massive, sprawling network of American asphalt has relied on an incredibly simple, entirely invisible, and highly efficient mechanism known as the motor fuel excise tax. Every single time a driver of a traditional internal combustion vehicle pulls up to a commercial gas station, inserts their credit card, and pumps liquid petroleum into their tank, they are simultaneously and unknowingly paying a highly calculated, multi-tiered combination of state and federal taxes embedded directly into the price of every single gallon. This system was historically brilliant in its execution because it operated as a perfect, frictionless proxy for road usage. If you drove a massive, inefficient commercial truck or if you possessed an incredibly long daily commute, you inherently burned significantly more fuel, and therefore you mathematically contributed a proportionately larger share of financial capital to maintain the physical roads you were actively degrading. It was an automated, strictly usage-based consumption tax that required absolutely no digital surveillance, zero cellular connectivity, and completely respected the geographical privacy of the American citizen. But as we observe historical trends leading up to this current year of 2026, the explosive, government-mandated adoption of battery electric vehicles has violently shattered this century-old economic equilibrium. Imagine if we analyze the profound financial panic currently unfolding on the desk of William, a senior transportation budget director for the state of Texas. William is staring at a catastrophic multi-billion-dollar structural deficit in his state highway trust fund. Every single month, tens of thousands of new electric vehicles are successfully registered within his jurisdiction. These drivers are proudly plugging their vehicles into their residential garage wall outlets or utilizing high-voltage commercial charging plazas, completely bypassing the traditional commercial gas pump. Consequently, they are contributing absolutely 0 cents in state or federal motor fuel taxes. The invisible automated revenue stream that funded the repaving of highways, the structural reinforcement of aging concrete bridges, and the deployment of emergency roadside services is rapidly evaporating right before William's eyes. However, the sheer financial terror for state infrastructure planners like William is compounded by a brutal, unforgiving principle of mechanical engineering and physical mass. An electric vehicle does not simply gracefully glide over the pavement without consequence. Due to the massive, highly dense electrochemical lithium-ion battery vaults resting completely across the floorboards, an electric vehicle is fundamentally and significantly heavier than its traditional gasoline-powered counterpart. A standard mid-sized gasoline sedan might possess a total curb weight of roughly 3,000 pounds. The exact same vehicle, completely re-engineered to accommodate a high-capacity electric drivetrain, heavily reinforced steel safety subframes to protect the volatile battery cells from side-impact collisions, and massive, multi-piston braking systems, routinely exceeds 5,000 pounds. When we examine the increasingly popular segment of fully electric heavy-duty pickup trucks and full-size sport utility vehicles dominating American roadways in 2026, we are routinely observing consumer vehicles tipping the scales at an astonishing 8,000 to 9,000 pounds. In the realm of civil engineering, there is a universally accepted mathematical equation known as the generalized fourth power law. This specific formula dictates that the structural damage a vehicle inflicts upon a paved asphalt surface does not simply increase linearly with the weight of the vehicle. It increases exponentially to the fourth power of the axle load. Therefore, when a completely silent, zero-emission electric pickup truck weighing 8,000 pounds constantly navigates a suburban neighborhood street, it is mathematically inflicting exponentially more microscopic shear force, deep structural fatigue, and aggregate separation into the asphalt base layers than a traditional lightweight gasoline sedan. Furthermore, the inherent mechanical design of an electric motor delivers absolute, instantaneous maximum rotational torque to the heavy rubber tires the exact millisecond the driver applies pressure to the accelerator pedal. This sudden, violent transfer of mechanical kinetic energy literally tears at the microscopic bitumen binders holding the roadway together, rapidly accelerating the formation of dangerous potholes and deep surface rutting. We are therefore observing a mathematically impossible and deeply paradoxical trajectory for state governments. They are being tasked with maintaining a sprawling highway system that is actively absorbing significantly more physical damage and rapid deterioration from incredibly heavy electric vehicles, while simultaneously losing the exact foundational tax revenue required to execute those critical repairs, because those exact same heavy vehicles do not consume taxable liquid fuel. To prevent the complete, systemic physical collapse of the American interstate system, state legislatures and regional transportation authorities across the country are actively executing a massive, highly controversial legislative pivot toward a radically different revenue model, known as the mileage-based user fee, frequently referred to in legislative documents as a vehicle miles traveled tax. They are no longer attempting to tax the chemical fuel you consume. They are actively preparing to directly tax the exact physical distance you travel. And the ultimate highly efficient tool they intend to utilize to perfectly execute this massive shift in public taxation is the exact same constant, inescapable stream of deeply personal vehicle telemetry data that we previously analyzed. William and his massive infrastructure department in Texas do not want to rely on the incredibly inefficient, historically fraudulent system of requiring citizens to voluntarily report their annual mechanical odometer readings during a yearly vehicle inspection. They require absolute, undeniable, real-time geographical precision to instantly capture lost revenue. Imagine if we examine the potential outcomes of this newly implemented system on a daily commuter named Richard, who recently purchased a heavy electric crossover vehicle. Richard no longer pays a tax hidden invisibly inside a gallon of fuel. Instead, because his modern vehicle is permanently tethered to a cellular network and possesses a highly advanced, military-grade internal GPS module, the vehicle's central telematics computer silently logs every single yard he travels. At the exact end of the month, Richard receives a highly detailed, itemized digital invoice directly from the State Department of Revenue. But this is not simply a flat, universally applied rate of 2 or 3 cents per mile. Because the state now possesses real-time, high-fidelity access to the exact spatial coordinates of millions of vehicles, they are actively implementing dynamic, algorithmic congestion pricing to forcibly manipulate human behavior and maximize tax extraction. When Richard navigates a desolate, rural county highway at 2 o'clock in the morning, the cellular uplink registers his location and algorithmically applies a very low, off-peak mileage rate. However, when Richard is mathematically forced by his corporate work schedule to merge onto a heavily congested, heavily degraded major interstate artery directly toward the downtown commercial district at precisely 8 o'clock on a Tuesday morning, the vehicle's telemetry instantly triggers a massive, localized surge pricing multiplier. The state algorithm heavily penalizes his vehicle for occupying highly demanded physical space during peak operational hours, dynamically raising his real-time taxation rate to 15 or 20 cents per single mile traveled. Richard is effectively experiencing airline-style, algorithmic surge pricing applied directly to his daily morning commute. This hyper-granular location-based taxation system introduces a deeply alarming socio-economic divide. Highly affluent executives possess the profound luxury of flexible remote work schedules, allowing them to completely bypass peak congestion pricing zones, or they possess the disposable income to simply absorb the astronomical costs of priority lane access. Meanwhile, the essential working-class demographic, including factory workers, nurses, and service industry professionals who are strictly mandated to physically arrive at highly centralized urban locations at specific, non-negotiable times, are disproportionately punished by the merciless surge pricing algorithm. The very concept of the open, publicly funded American road is rapidly transitioning into a highly restrictive, digitally gated, pay-per-use corporate utility, where your exact physical movements are mathematically monetized against you in real time. But while the average consumer is entirely distracted by this invisible, deeply invasive financial surveillance draining their bank accounts mile by mile, a much more immediate, purely physical, and potentially lethal catastrophe is quietly looming directly on the horizon. We are blindly launching millions of mathematically heavy, aggressively accelerating, deeply heavy kinetic missiles onto a fragile, aging physical infrastructure network that was completely and fundamentally engineered for a drastically lighter era. And when we examine the precise mathematical tolerance of the steel guardrails currently lining the cliffs of our mountain highways, and the load-bearing concrete pillars supporting the massive parking garages directly beneath our densely populated urban centers, we uncover a terrifying structural reality that no one in the automotive industry is willing to publicly address. Let us systematically examine the exact engineering mathematics that dictate the terrifying reality of our national highway safety infrastructure. For over half a century, the intricate network of corrugated steel guardrails, tensioned cable barriers, and heavily reinforced concrete median dividers spanning across the United States was meticulously designed, rigorously tested, and physically installed based on a very specific, historically established set of assumptions regarding the average weight and the specific center of gravity of the American passenger vehicle. When civil engineers in the 1980s and 1990s drafted the foundational blueprints for these life-saving structures, they were calculating the kinetic energy of a traditional gasoline-powered sedan weighing roughly 3,000 pounds, or perhaps a standard half-ton pickup truck weighing slightly under 5,000 pounds. The physical testing protocols, widely known within the industry as the Manual for Assessing Safety Hardware, explicitly utilized a 5,000-pound test vehicle striking a steel barrier at 62 miles per hour at a 25-degree angle. This was the absolute maximum threshold of civilian structural tolerance. Now fast forward to the current year of 2026, and imagine the highly realistic, profoundly concerning case study of Marcus. Marcus is a software engineer commuting down the steep, winding mountain passes of Interstate 70 in the Colorado Rockies during a severe winter storm. Marcus is driving a top-tier, exceptionally popular brand-new electric pickup truck, Because this specific vehicle is equipped with a massive, dual-layer, 200 kilowatt-hour lithium-ion battery pack, structurally integrated into its steel frame to provide sufficient driving range in freezing temperatures, the vehicle tips the scales at a staggering 8,500 pounds. Furthermore, unlike a traditional gasoline truck where the heavy internal combustion engine is mounted high up beneath the front hood, the entirety of that massive chemical battery weight in Marcus's electric vehicle is distributed completely flat along the bottom floorboard, resulting in an exceptionally low center of gravity. If Marcus hits a patch of black ice and loses control of this massive kinetic projectile, sliding directly into a standard steel guardrail at highway speeds, the historical safety infrastructure is rendered entirely obsolete. The foundational laws of physics cannot be negotiated with or updated via a software patch. Because kinetic energy increases linearly with mass, Marcus's 8,500-pound electric truck carries nearly double the destructive, forward-moving energy of the traditional vehicles that the guardrail was mathematically engineered to stop. When the heavy electric vehicle impacts the steel ribbon, it does not safely deflect and redirect the truck back into the lane as intended. Instead, the sheer overwhelming mass completely overwhelms the structural integrity of the wooden or steel support posts anchored into the soil. The steel ribbon violently snaps like a brittle twig, completely failing to prevent the massive vehicle from plummeting down the steep mountain embankment. Furthermore, historical trends from recent independent crash testing facilities reveal a second, deeply disturbing potential outcome directly related to the extremely low center of gravity inherent to electric vehicle architecture. When a heavy electric sedan or crossover strikes a standard concrete jersey barrier, the extreme weight located exclusively at the floorboard changes the fundamental dynamics of the collision. Instead of the vehicle's front crumple zones absorbing the impact and the car sliding along the concrete wall, the low, dense battery pack acts as a massive battering ram that easily lifts the lighter, upper portion of the vehicle completely over the 32-inch concrete divider, vaulting the massive machine directly into oncoming highway traffic. The entire physical safety net of the American interstate system is currently operating on a massive, highly dangerous mathematical deficit, entirely unequipped to handle the silent, rolling tanks currently taking over the fast lane. But this mathematical infrastructure crisis extends far beyond the rural mountain passes. It is actively metastasizing deep within the dense, highly populated concrete core of every major American city. To understand the sheer magnitude of this looming architectural disaster, we must transition our focus from horizontal highway barriers to vertical structural engineering. Imagine if we analyze the specific, daily routine of a corporate attorney named Sarah, who works in the financial district of downtown Chicago in 2026. Every morning, Sarah navigates her 7,000-pound luxury electric sport utility vehicle into a massive, multi-level concrete parking garage that was originally designed and constructed in the late 1970s. When the structural engineers poured the reinforced concrete floor slabs for this massive facility 50 years ago, they calculated the required structural integrity based on a deeply ingrained architectural metric known as the live load capacity. For decades, the standard building code for a commercial parking structure dictated a live load requirement of merely 40 pounds per square foot. The mathematical assumption was that the facility would be populated by a diverse, relatively lightweight mixture of compact cars and mid-sized sedans, perfectly distributing their mechanical weight across the massive concrete spans resting between the load-bearing pillars. However, the explosive, mandated adoption of battery electric vehicles has completely destroyed those foundational engineering assumptions. When Sarah parks her 7,000-pound vehicle on the fourth floor of this aging structure, she is not an isolated anomaly. She is surrounded by hundreds of other commuters who have also transitioned to massive, battery-laden electric crossovers and incredibly heavy electric pickup trucks. The cumulative, localized physical weight bearing down on the 50-year-old concrete slab is suddenly exponentially higher than the original engineers ever mathematically modeled for or anticipated. This extreme, continuous pressure induces a terrifying structural phenomenon known as punching shear. The massive, concentrated point loads resting beneath the four heavy rubber tires of these electric vehicles force the aging concrete to aggressively flex and microfracture around the internal steel rebar matrix. In coastal cities or environments like Chicago that heavily utilize corrosive road salts during the winter, that internal steel rebar has already been quietly degrading, rusting, and losing its tensile strength for decades. When you combine heavily compromised, aging concrete infrastructure with the sudden unprecedented introduction of millions of exceptionally heavy electric vehicles, you are mathematically engineering a scenario for catastrophic structural failure. We are actively observing potential outcomes where entire floor slabs of multi-level parking structures could suddenly collapse under the sheer, unmitigated weight of a localized cluster of electric vehicles, triggering a devastating pancake effect that destroys everything below it. And if a localized structural collapse were to occur within a dense, subterranean parking garage, the heavy electric vehicles introduce a secondary, highly lethal chemical component that traditional urban fire departments are entirely unequipped to manage. If falling concrete debris physically ruptures the armored casing of a fully charged, high-capacity lithium-ion battery pack, it instantly triggers an unstoppable, self-sustaining chemical chain reaction known as thermal runaway. Unlike a traditional gasoline fire that requires ambient oxygen to burn and can be rapidly smothered with chemical foam or massive amounts of water, a lithium-ion battery fire generates its own highly combustible oxygen internally as the metal oxides degrade. The thermal event burns at temperatures exceeding 3,000 degrees Fahrenheit, a heat so intensely ferocious that it actively melts the structural steel support beams of the surrounding building. A single electric vehicle burning inside a confined, subterranean urban parking structure possesses the potential to fundamentally compromise the structural integrity of the massive residential or commercial skyscraper resting directly above it. We are systematically overpowering the mathematical limits of our physical world. The concrete beneath our tires, the steel barriers protecting our families, and the massive electrical grid powering our homes are all simultaneously screaming under the immense, unyielding pressure of this rapid, highly mandated transition. The average American consumer is entirely consumed by the daily anxieties of finding a working charging station, battling extreme battery degradation, and navigating the oppressive, algorithmically driven financial surveillance state that has infected their dashboard. Yet, while the public is completely distracted by these immediate, localized logistical nightmares, they are completely missing the massive, terrifying macroeconomic endgame unfolding on the global stage. The aggressive systemic push to eliminate the internal combustion engine is not merely about environmental preservation or reducing local emissions. It is the foundational maneuver in a massive, high-stakes geopolitical war for the total dominance of the 21st century. And as we trace the flow of trillions of dollars moving silently between multinational defense contractors, heavily subsidized technology conglomerates, and the highest levels of the federal government, we will uncover the exact highly classified reason why you are being systematically forced out of your gasoline vehicle, and precisely what this looming global conflict means for the future of the American working class. To understand this massive geopolitical shift, we must fundamentally redefine what a vehicle actually represents to the United States government in the year 2026. For the entire 20th century, the global economic order was entirely dictated by the continuous, uninterrupted flow of liquid petroleum. The American military apparatus, the strength of the United States dollar, and the foundation of international diplomacy were all inextricably linked to securing access to massive, subterranean oceans of crude oil located in deeply unstable regions of the Middle East. When you purchased a gasoline vehicle, you were unknowingly participating in a massive global petrodollar recycling system. However, historical trends over the past decade have demonstrated that maintaining this petroleum-based empire is becoming mathematically and strategically unsustainable. The new global superpower hierarchy of the 21st century is no longer determined by who controls the oil fields. It is exclusively determined by who controls the highly concentrated processing, refining, and manufacturing of critical battery minerals and advanced semiconductor microchips. The electric vehicle resting in your suburban driveway is not merely a mode of personal transportation. It is a highly strategic, heavily subsidized node in a desperate, multi-trillion-dollar national security initiative designed to forcefully decouple the American economy from foreign energy dependence. The federal government is not aggressively pushing the elimination of the internal combustion engine because they are solely concerned with localized tailpipe emissions. They are orchestrating this massive societal pivot because they are terrifyingly aware that if a foreign adversary corners the global market on lithium-ion battery production and the subsequent autonomous software that controls these vehicles, the United States will permanently lose its status as the dominant industrial superpower. We are witnessing the rapid, forceful reconstruction of the American industrial base, completely funded by massive federal subsidies and taxpayer capital, to build a domestic, closed-loop supply chain that can survive a potential global trade embargo or a catastrophic kinetic conflict over critical maritime shipping lanes. But this monumental top-down restructuring of the global economic order is actively triggering a massive, devastating shockwave that is directly striking the very heart of the American working class. Imagine if we analyze the specific, deeply concerning reality of James, a third-generation automotive assembly line worker living in the historic industrial corridors of Flint, Michigan, in this current year of 2026. For decades, James and his ancestors built their entire middle-class existence, their pensions, and their localized economies on the extreme mechanical complexity of the internal combustion engine. A traditional gasoline-powered powertrain is a brilliantly engineered mechanical symphony consisting of roughly 2,000 distinct, highly intricate moving parts. It requires pistons, valves, camshafts, fuel injectors, massive multi-speed transmissions, and complex exhaust routing systems. Manufacturing, machining, assembling, and maintaining those 2,000 physical parts required a massive, highly skilled, deeply entrenched blue-collar workforce distributed across thousands of domestic supplier factories throughout the American Midwest. However, when James walks onto the floor of a newly retrofitted, state-of-the-art electric vehicle manufacturing plant today, he is completely surrounded by a terrifyingly silent, highly automated reality. The mechanical complexity that sustained his family for 3 generations has been entirely eradicated. The drivetrain of a modern electric vehicle is shockingly simple in its physical construction. It primarily consists of a massive chemical battery pack, a power inverter, and an electric motor containing roughly 20 moving parts. The entire mechanical transmission has been replaced by a single-speed reduction gear. The exhaust system is completely gone. The complex fuel delivery network has been replaced by heavy-gauge copper wiring. Extensive industrial case studies and labor analyses conducted over the past 36 months reveal a brutal mathematical truth. Assembling an electric vehicle requires roughly 30 to 40% less human labor than assembling a traditional gasoline vehicle. James is actively watching his highly specialized mechanical skills become instantly obsolete, replaced by millions of lines of proprietary software code and massive, highly precise robotic arms that never require a pension, never take a sick day, and never demand a collective bargaining agreement. The transition to electric propulsion is quietly triggering one of the largest, most severe wealth transfers and labor displacements in modern industrial history. The high-paying, secure manufacturing jobs of the 20th century are being violently stripped away from the physical assembly line workers in the Midwest and rapidly transferred to highly educated, fiercely expensive software engineers residing in the tech corridors of Silicon Valley, and chemical processing specialists operating massive, heavily subsidized battery plants in the Sun Belt. James is staring down a future where the traditional pathway to the American middle class through physical mechanical labor is being systematically dismantled and replaced by an incredibly elite, deeply exclusive digital and chemical economy. Furthermore, the economic pressure on the remaining domestic workforce is aggressively compounding because legacy American automakers are locked in a desperate, existential battle for survival against an onslaught of heavily subsidized, incredibly cheap foreign electric vehicles actively attempting to flood the global market. To compete with overseas manufacturing monopolies that possess massive structural advantages in critical mineral refining and deeply suppressed labor costs, American corporations are being forced to ruthlessly optimize their operations. They are rapidly implementing advanced artificial intelligence, machine learning algorithms, and massive industrial gigacasting machines that can instantly inject molten aluminum to form the entire rear underbody of a vehicle in a single massive piece, instantly eliminating the need for hundreds of individual steel stampings and the human workers required to weld them together. The American highway is being completely conquered by electric vehicles, but the massive factories producing them are rapidly becoming desolate, humanless environments. We have systematically pulled back the pristine, heavily marketed curtain of the great electric transition to reveal the raw, unforgiving mechanical, economic, and geopolitical realities resting beneath the surface. You now understand the severe microscopic chemical degradation destroying the secondary used car market, the terrifying physical limitations of our aging electrical grid, the deeply invasive algorithmic surveillance monetizing your daily commute, and the massive global conflict dictating the future of American industrial power. The vehicle sitting in your garage is no longer just a mechanical tool. It is a heavily restricted, permanently tethered, deeply monitored chemical vault that is fundamentally reshaping the physical architecture and the economic foundation of the United States. You possess the deep, technical understanding required to navigate this chaotic transition, protect your financial assets, and see exactly what is actually happening beneath the asphalt. But while we have meticulously broken down the terrifying reality of the machines currently dominating our highways, there is a much darker, incredibly secretive technological revolution happening entirely behind closed doors that will permanently alter the very definition of human transportation. The vehicles of 2026 are actively learning. They are silently communicating with each other across invisible neural networks, and they are rapidly preparing for a highly coordinated software update that will entirely remove the human driver from the equation. And when we examine the highly classified, deeply alarming potential outcomes of the impending autonomous swarm currently being tested on our public roads, you will realize that losing control of your steering wheel is just the very beginning.